Alright guys, let's continue our journey in making a simple robot. This is part two. We're going to be talking about the body. So when we think about the body, we got to think, okay, what makes up the body? Well, the feet do. That's part of it, the feet and legs. We have the arms and the hands. That is part of it. And also the head. All these parts are body parts. So the first question I have is, what does the body do? Well, thinking about the human body, a few things come to mind. Well, we have all the body parts. We have the bones, we have the muscles, and then we have the joints. These things come together to give our body strength and also movement. Helps us move. Now, the robot, it's kind of like that, but the difference is that the body parts are metal, plastic, and wood. And then we have not muscles, we have motors, which I circled here. So motors are the things that gives us the power to move things within our robot. And then we have the gears. Gears connect different parts of the robot so that the motors can move the entire robot. And those are gears are usually circular that you see here. And these things all come together and they give us strength and movement. Now, who builds the robot's body? Who's responsible for that? Well, the word here is mechanical engineer. So mechanical engineers work on bodies of the robot. An example is someone like a mechanic. So that's where the word mechanic comes from. People who work on cars, those are mechanical engineers, all the gears and motors and stuff. And then if you like space shuttles, if you want to design airplanes or space shuttles to go to outer space, a lot of times those are mechanical engineers. And then we also have people who build bridges, figuring out how to make a strong bridge so that it doesn't fall down. That would be a mechanical engineer as well. So let's go ahead and open our box and look at some of our parts here. We have one servo motor. It's a gray color here, and one servo horn that's going to attach to the servo motor. We have a screw that's going to help us attach the servo horn to the servo motor, and a screwdriver to help us screw it in. So later in the instructions, you'll learn how to put that all together. But for now, I want to talk about this guy, the servo motor. Okay, so we're going to talk about servo motor, but first let's talk about motors in general. So there are a few different types of motors. This one's like a car motor. This is actually called a DC motor. Now, the one that's in your kit is actually a servo motor. So it's a different one. Okay, we have DC motor and servo. Let's first talk about DC motors. All right, so when we think of DC motors, we gotta first think of a circle, and you'll see how this makes sense. So a circle can actually be explained by this little tool here called a protractor. And I want you to look at this tool. They have all these tick marks. All these tick marks, they represent something called a degree. And there's many degrees that go all the way around. It starts at number 0. So you see there's a 0 there for the arrow is. And if you keep going up, if you get to this point, it becomes 90 degrees. That means there's 90 little tick marks from 0 to 9 to that point. And then if you get to this point, it says 180 degrees. So what about down here? How many degrees is down there? We're going to add another protractor. So actually keep counting, and it becomes 270 degrees down there. So we're just going all the way around, and you get back to the beginning, and here's kind of tricky. It's not 0, it's 360 degrees. And that's how it works when you count in degrees around a circle. If you get all the way to the beginning, it becomes 360. So what do we learn here? DC motors move a full circle, which is the same as 360 degrees. Okay, so DC motors move 360 degrees. So where do DC motors, where are they used? Well, car wheels, they go full circle, full round and round. And so that's a DC motor. Also, you've seen these in a carnival or something. A Ferris wheel also goes round and round. That's a DC motor. Also, this guy, a blender, you have a motor that spins a blade round and round. That's a DC motor. Also, clocks. Clocks also go round and round, full circle. So you could build a clock using DC motors. And then when we get hot, we turn these guys on. It's a fan. When you turn it on, it just goes round and round. So that's also a DC motor. So let's talk about servo motors, which is what we're going to use in this simple robot. So let's go back and, we have the circle again. And we're going to put the protractor just like before, and we're going to look at the degrees just like before. So everything is the same so far. This little area, this little place is 0 degrees. We keep going just like before. This part is 90 degrees. And if you can remember, when we get to here, it is 180 degrees. So we're at half a circle now. Now we're going to stop counting. We're going to say that's all it can move. So we're going to erase that part. And so servo motors only move 180 degrees. So what did we learn? Servo motors can only move half a circle, because we only see half a circle, which is the same as 180 degrees. So that's what we gotta know now. Servos only move half a circle, 180 degrees. So the car here, I'm drawing it, but it's not the wheel that I want to bring your attention to, but rather the windshield wiper. The windshield wiper only goes half a circle. If you remember, if you notice driving around, it only goes half a circle. Also, doors can only open half a circle. And also catapults, when it launches things, it also only moves half a circle. Another example here is when you wave goodbye to someone, you wave your hand, kind of like a windshield wiper, back and forth. So these are all robots that you can make with the servo motor. All right, so that's all for now. The next up is part 3, where you have to learn about the robot brain.